Welcome to Precalculus Concept 25D. Underneath right triangle trig, we're going to use right triangle trig to solve applied problems. And there's only 4 boxes. The very first box that I have for you here is all about the terms that we're going to be using when we talk about solving applied problems. Okay, so the first term is going to be this, what we call the observer, or the person who's making the observation. So you have to have a person in a line of sight, okay? The horizon is going to be considered wherever their eyes look out straight. So that's the horizontal. Notice the horizon is not necessarily the ground, but it will always be parallel to the ground, okay? Let's say that if you're standing on a balcony and you're looking up at an airplane, then you're going to have an angle of elevation from the line of sight from your eyes to the plane from the horizon. So we're only talking about this little angle right inside here, okay? Similarly, if you're looking down at like a car or something, then you're going to have what's known as the angle of depression, and that is the angle that is measured from the horizontal down to the car. So that'd be this angle down here. This is the angle of depression, and if you're looking up, that's the angle of elevation, okay? So these words and these phrases need to be understood before we can continue to talk about these problems. So you're going to see line of sight from the observer to the angle of depression, or line of sight from the observer below to the angle of depression, or elevation or depression, and then the horizon is wherever the person is standing straight out, okay? So there we go. Okay, here's example number 2. I just took the picture from the book, but I will read you the directions. They say this. It says, sighting the top of a building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. Okay, so let's dissect all of these things here. It says the angle of elevation, so that means from the person's line of sight out, measured all the way up, is an angle of 22 degrees, okay? We know that the height from where the line of sight is to the ground is an extra 5 feet. So we are looking for the full height of the building, given that we know this much. So the trick here, ladies and gentlemen, is just to simply find the right triangle, okay? So if I draw a very, very simplified version, then this would be 22 degrees, this would be 300, and this would be, we'll call A in the picture. And we're going to assume that that building is right angle to the ground. So all we have to do is figure out which trig function we have to use, given that we have an opposite side to an angle, and we have an adjacent side. So I'm going to go ahead and choose to use the tangent because that's the one that makes the most sense. So the tangent of 22 degrees is the ratio of the opposite side, which happens to be A, divided by the adjacent side, which happens to be 300 feet. If I solve this algebraically for A, I'm going to multiply both sides by 300, okay? And I'll get A is approximately equal to 300 times the tangent of 22 degrees. So you do need your calculator for this one. So I'm going to take my calculator out, and I'm going to clear whatever's on the screen, make sure I'm in degree mode, and take the tangent of 22 degrees, get that answer, and then multiply it by 300, which happens to be the length of the adjacent side of my right triangle, and I'm getting 121.2, okay? So A is approximately 121.2 feet. But remember that the line of sight was located 5 feet above the ground, so if I add 5 feet to this, I would get 126.2 feet. So therefore, the height of the building is approximately 126.2 feet. Okay, here's box number 3. It says, the irregular blue shape of the lake represents a picture of a lake that's close by. The distance across the lake, which is they're considering A, is unknown. To find this distance, a surveyor took the measurements shown in the figure. What is the distance across the lake? All right, so here's what they're looking for, right? They have a right triangle. We want to know this distance right here, which we're calling A. So again, all we're going to do is we're going to use the tangent of 24 degrees. Has to be the ratio of A divided by 750 yards. So therefore, A is just going to be 750 multiplied by the tangent of 24 degrees. So again, I need the calculator out. So I'm going to take the tangent of 24 degrees, and then I'm going to get that answer and multiply it by 750 yards. So therefore, the distance across the lake is approximately 334 yards if I just go to the nearest yard. So A is approximately 334 yards. The book or the directions or the test will tell you exactly how many units to round to, so don't worry about that. Okay, box number 4 is a different type of example where we're going to have to use an inverse trig function, so I will show you exactly how to do that. It says here, a building that is 21 meters tall casts a shadow 25 meters long. Find the angle of elevation of the sun to the nearest degree. Okay, so the picture really tells you the situation that's going on. You have the sun in the sky, and it's creating some kind of an angle here, and that's the angle that we wish to know. So we have the height of the building is 21 meters, the shadow is 25 meters. So here we go. I know that the tangent of the angle that I am looking for is equal to the opposite side, which is 21, divided by the adjacent side, which is 25. Okay? So therefore, the tangent of my angle theta is equal to whatever that fraction happens to be. Okay? But I don't necessarily know exactly what the angle is, so how do I get it? Okay? So this is 21/25. I don't want to just plug in 21/25 into my calculator and then say that that's the angle, because that doesn't make any sense. So what we do is we say that theta is equal to the inverse tangent of 21/25. So what does that mean, right? This statement right here says the tangent of an angle has a ratio of 21/25. This statement says the angle that you're looking for has a ratio that is 21/25. So where do you find this button on the calculator? Literally, it is the blue above where it says tangent, right? So what this is you go second tangent, and notice that in your calculator you have a little -1. That means the angle whose tangent is a value of, and then you plug in the value, 21 divided by 25. Okay? So what do we get? We get 40.030. So to put this into context for you, if I took the tangent of 40.030 and then pushed enter, what fraction do you think that is, you guys? That's the fraction of 21/25. Look, 21 divided by 25. So that's what you're doing right there. So there's your 0.84. So the inverse tangent gives you the angle whose tangent is worth a ratio of 21/25. So in this case, it would be 40.03 degrees is the angle of elevation that we're looking for. Theta is approximately 40.03 degrees angle of elevation to the sky.